Hello, today in this lecture, uh, we will be discussing on particle accelerators. Okay, so what is an accelerator? Accelerator is a device used to accelerate and thus impart high kinetic energy to charged particles and thereby producing a beam of high energy particles. Now, why these high energy particles are needed? These high energy particles are needed especially in artificial transmutation, understanding the nuclear structure, nuclear scattering, nuclear properties, including the nature of nuclear forces. Now, what are the essential parts of an accelerator? So, an accelerator primarily consists of an ion source, a collimator, a suitable element for acceleration of particles using either electric field or magnetic fields along specific trajectories, and it should contain also a reflector. Now, what are the types of accelerators? Based on the uh, nature of accelerating field applied, accelerators are classified into two groups. One is electrostatic and another one is electrodynamic. Now, what is electrostatic accelerators? Electrostatic accelerators are those which use static electric fields to accelerate particles. The most common electrostatic accelerator are Cockcroft-Walton generator and Pendejof generator. Now, in this context, I want to say that different types of accelerators are designed since 1930s and continuously being improved to impart energies varying from few MeV to several P. But accelerators are also designed with a view to accelerate a number of particles, namely protons, neutrons, alpha particles, electrons. Okay? Why accelerators are needed? We know that the de Broglie wavelength of a particle is given by lambda equals to h upon p. So what is h, which is the Planck's constant, and p is the linear momentum. Also, it is known from optics that to see the structure in detail of an object of linear dimension d, the wavelength must be less than or equal to the dimension. So for this wavelength, your momentum must be greater than or equal to h by p. Hence, to detect nuclear particle, high momentum and hence high energies are needed. So, since nuclear particles are not visible to naked eye and these particles are of very, very small size, accordingly, in order to detect the nuclear particle, high momentum, uh, that means highly energetic charged particles are required. Okay? So now let me discuss about the few accelerators of early days. First of all, uh, Cockcroft-Walton voltage multiplier. As you can see, that it is a DC particle accelerator in which a stream of electrons was used to ionize the hydrogen gas and produce protons. The basic principle consists of charging a set of capacitors in parallel and discharging them in series to add up their potential. It is essentially a combination of capacitors and rectifiers. And using this acceleration of protons are made up to a potential difference of 0.15 MeV. However, the improved version of these accelerators is capable of producing beam of energy 3 MeV. Then, in the year 1931, Van de Graaff electrostatic generator was designed uh, by Van de Graaff, uh, and the basic principle of this generator is that the potential of a hollow conductor can be increased to a very high value by repeated transfer of charge from one hollow conductor to another by internal contact. And using this, one can accelerate protons, deuterons up to an energy of about 12 MeV, beyond which air insulation breaks down. It can also be used to accelerate electrons by a reversal of potentials of spray voltage and using a hot filament as source of electrons. And one of the most important advantage you can say in Van de Graaff electricity generator is that the output voltage remains almost constant, and constancy is very much stable. Sensitivity is very high. Okay? Then next is tandem electrostatic accelerator. It was simply the improved version of uh, Van de Graaff generator. It accelerates particle in two stages and is more economical. First stage, negative ions are produced at ground potential at one end and accelerated by the positive potential at the terminal, which is in the middle of a long pressure tank. Second stage. What is done in the second stage? When the ions are still inside the positive terminal, they enter a gas-containing canal called stripper and are stripped of their electrons to become positive ions and are accelerated, being repelled from the positive terminal to the ground potential to reach the target. So it can produce heavy ion beams of energy up to 30 MeV. Next, the most commonly used in the 1930s, commonly used accelerator in the 1930s was RINA, which was developed by Luis Alvarez and his co-workers, which can accelerate charged particles up to 32 MeV. And what is the principle underlying this? The main principle behind the working of linear accelerator is to increase the velocity of a charged particle in successive steps along a straight line when they are subjected repeatedly to an accelerating electric field. What are the important advantages? It does not require any magnet to guide the particle. They emerge from the machine automatically as an excellent collimated beam and hit the target directly, like the circular type of machines where emergent beam spreads out. Emergent beam is highly intense and homogeneous. Radiation loss is also less, unlike circular machines. Now, what are the disadvantages of Linux? It is not possible to accelerate electrons to a very high energy as the electron becomes relativistic even at few MeV and start moving out of phase. It requires ultra high frequency acceleration for synchronization. To obtain high energy, one requires heavy ion carrying large charges, a long accelerator. Later on, in the year 1934, um, E. O. Lorentz and M. S. Livingstone uh, jointly designed one accelerating device known as cyclotron, which can speed up charged particles in successive steps under the combined influence of electric and magnetic fields along circular trajectories. A cyclotron is a device that is used to accelerate charged particles to high energies without use of high voltage. It is a circular particle accelerator capable of generating particles energies between 1 MeV to 100 MeV. Accelerate charged particles like protons, neutrons, etc. ions using electric and magnetic field. Cyclotron was one of the earliest type of particle accelerators and is still used as the first stage of some large multi-stage particle accelerator. One of the most interesting applications of motion of charged particles in electric and magnetic fields is cyclotron. Cyclotron produce very high energy charged particle. Kinetic energy is given by half mv square. And working principle of cyclotron is that a charged particle moving normal that is perpendicular to a magnetic field experiences magnetic Lorentz force due to which the particle moves in a circular path. So Lorentz force is the basic principle of cyclotron. Conceptually, this device is very simple, but it has huge uses in the field of engineering physics and medicine. Thank you.